In this example, we have 7 pi over 2 as an angle, and we're supposed to find the secant, cosecant, tangent, and cotangent. Okay, so let's come down here and write the definitions. The sine is the y on the unit circle, and the cosine is the x on the unit circle. Tangent is just sine over cosine. The other 4 trig functions come from the sine and cosine. Let me show this here. Okay, so the other ones just come, so this is cosecant, and that's just 1 over sine. These are reciprocals, by the way. They're upside down. The other 3 are reciprocals of the first 3. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is upside down to tangent, so it's cosine over sine, right? Because that's upside down of that. Okay, so the right 3 are just reciprocals of the first 3. So notice they're all just coming from sine and cosine. And we get sine and cosine off the unit circle, so we go get sine and cosine from the unit circle, and then the other 4 all come from what we got for sine and cosine from the unit circle. All right, so first, though, we got to deal with our angle. Our angle, theta here, theta is 7 pi over 2. Theta is just a Greek letter, like T is an English letter. It's a Greek T, basically. Theta is 7 pi over 2. Now, notice that we need to subtract 2 pi because that's more than 2 pi. So, you can always add. You can always add or subtract 2 pi, and you end in the same spot on the unit circle because 2 pi is 1 full rotation, isn't it? So you can always do that. That's always acceptable to do. You can always add or subtract 2 pi because that's a full rotation. You'll end in the same spot. So in this case, I'm subtracting 2 pi. Well, why can't I just go to the unit circle? Well, the unit circle is only 1 rotation. It ends at 2 pi. There's no 7 pi over 2 here. That's more than a full rotation. The unit circle only has the values within 1 rotation. So if they give you something that's more than a full rotation, then you need to subtract the extra rotation. So subtract means multiply top and bottom by 2 to get common denominator. So we'll have 7 pi over 2 minus 4 pi over 2, which is 3 pi over 2. So that is on our unit circle. That's the same spot, right? Because we just subtracted 1 full rotation. 3 pi over 2 right there. So here's the cosine, here's the sine, right? The x is the cosine, the y is the sine. Cosine is 0, so we'll take that with us. In fact, let me just write it right here. So the cosine is 0, the sine is -1. Okay, so then let's figure these various pieces out. What's the tangent going to be? Sine over cosine. -1 over 0. What is that? That does not exist. That's actually infinity is what it is. Because 0 goes into anything an infinite amount of times. Right? Are you aware of that? 0 in the bottom of a fraction is actually infinity. That's why we say does not exist, meaning it's not a real number. There's no actual number that exists there. 1 over sine, what is sine again? -1. So this is just -1 for the cosecant. Let's try this one. 1 over cosine, cosine 0, 1 over 0. That's d in e again, because you cannot have 0 in the bottom of a fraction. Let me show that real quick. If you take 10 divided by 2, we know that's 5 because 2 goes into 10 5 times. A fraction means divide, of course. If you have 0 on the top of a fraction, how many times does 2 go into 0? Well, 0 times, right? 0 on the top is 0. But if you have 0 in the bottom, 0 goes into 2, infinite. You see 0 on the bottom is infinite. That's why we say does not exist, because there's no real number that exists. All right, let's finish this up. Cotangent, cosine over sine, 0 over -1. Whoops. So what's 0 on the top of a fraction? That's just 0, isn't it? So there we go. We found the other 4 trig functions, all coming from cosine being 0 and sine being -1, which we found on the unit circle when we looked for 3 pi over 2, which we got by taking our original 7 pi over 2 and subtracting 1 rotation as a common denominator. And right, because you can always take away 1 full rotation or add, you're in the same spot. So there we go.